This video will demonstrate the half-life of radioactive elements and begin to show why this is a concern for waste storage. You will need a large amount of dice for this experiment. In this example, we're using 200. You will also need some kind of box for shaking the dice. We're using a cardboard box we found in the recycling. You will shake the dice around in the box and dump them out. It helps to have a carpeted surface to dump them out on because then they don't scatter everywhere. Then you will pick up the dice that have the one side facing up and set them aside, and return the rest of the dice to the box. Then you repeat the procedure of shaking up the dice, dumping them out, and removing the ones, until all of the dice have been removed. You should be keeping track of how many dice were removed per roll. This will be important for our graphing later. Here we are at the end of all my trials. I've lined up each pile in the order that they were removed. And now it's time to count how many were removed per roll. This is the raw data that we will be using to make our graph. The columns of our spreadsheet are going to be the number of rolls, the number of dice removed, and the number of dice remaining. Our first data point is going to be roll 0, 0 dice removed, and 200 dice remaining, because that's how many we started with. We are going to use a fairly basic formula to get the number of dice remaining as we type in the number of dice removed. This will make it easier for us to make a realistic radioactive decay curve. Once this equation is entered, you can drag it down so it will be duplicated for the rest of the data points, and then you can enter in the rest of your data. We created a graph before we finished entering the data to make the process a little more visually appealing. Now we're going to go ahead and type in the rest of our data points. Keep an eye on the graph on the right side of the screen. It should be pretty interesting to watch. Now it's time to analyze our graph. What we really care about with radioactive decay is the half-life, or the amount of time it takes for half of the original amount of isotope to decay. We can get a pretty good estimate of this without any math by simply looking at our graph and finding how long it took for half of the original amount to be left. In our case, we're looking for how long it took for 100 dice to be removed. It took about 4 rolls for us to have 100 dice remaining. We can get a better estimate of the half-life by having the previous number and finding the number of rolls it took us to get to that point. While it took us 4 rolls to get to 100 dice, 5 more to get to 50, and 4 more to get to 25. We can take the average of all of these half-lives to find out what the approximate half-life is for this example. We found a half-life of about 4.2 rolls for this experiment. This corresponds to a unit of time it would take for half of a radioisotope to decay. This has significant consequences for the storage of radioactive material that will be explained during the lesson.